Good morning, y'all. Now, before I get into this one, I want to set the tone right up front, because Yellowstone content online has a reputation for going straight to doomsday. And that is not what I'm about to do to you this morning. What I want to do instead is walk y'all through something genuinely interesting that happened at Yellowstone recently. A small hydrothermal explosion that gave scientists an almost unheard of look at what precedes these events, and explain exactly what it means, what it doesn't mean, and why the folks who monitor that caldera every single day are treating it as one of the most valuable data points they've gotten in years. So let's get into the science, because I think once y'all understand what actually happened, you're going to find it a lot more fascinating than frightening. Here's the setup. Early on the morning of Saturday, right around 5:09 a.m. to Mountain Time, monitoring equipment in Biscuit Basin, that's an area of Yellowstone just north of the more famous Midway Geyser Basin, picked up something happening. The instruments recorded anomalous seismic energy along with what's called infrasound, which is low-frequency acoustic energy, below the range of human hearing, and both signals were coming from the direction of a feature called Black Diamond Pool. Now, that name might ring a bell for some of y'all, because Black Diamond Pool was the site of a much more dramatic, well-documented hydrothermal explosion back in July of 2024. So when scientists saw activity centered right back on that same spot 2 years later, they knew immediately this deserved a close look. As the sun came up that morning, park staff noticed the Firehole River, which runs right through that basin, had turned a light gray, milky color, and that discoloration was visible for nearly 4 miles downstream, all the way to Midway Geyser Basin. 2 brand new runoff channels had opened up, draining directly from Biscuit Basin into the river. So naturally, the first question on everyone's mind was, did Black Diamond Pool just do it again? Did we just witness a repeat of the 2024 event? And this is where the story gets genuinely interesting from a science standpoint, because when the geology team pulled the data, the answer turned out to be no. Not exactly. Let me explain what a hydrothermal explosion actually is, because I think this term gets thrown around online without much context. And it is fundamentally different from a volcanic eruption, which is the distinction I most want y'all to walk away with today. A hydrothermal explosion has nothing to do with magma reaching the surface. Instead, it happens when water trapped underground, superheated by the geothermal heat from the volcanic system below, flashes instantly into steam. Think about what happens when you crack open a pressure cooker too fast. That violent instantaneous expansion as trapped liquid turns to vapor. That is essentially what's happening underground at spots like Biscuit Basin, just on a scale involving rock, soil, and boiling water instead of a stovetop. These events can throw rock and debris into the air, carve out new craters and fissures, and send scalding water and mud flying, and they can be genuinely dangerous to anyone standing nearby. But they are a surface and near-surface phenomenon. They are not a sign that magma is moving, and they are not a precursor to a volcanic eruption. Yellowstone actually experiences small hydrothermal explosions on a regular basis. Most are so minor they barely make the news. What made this one at Biscuit Basin different wasn't necessarily its size. This explosion was actually smaller than the 2024 event at the same location. It was where it happened, relative to Yellowstone's monitoring network. And this is the piece I really want you all to understand, because it's the actual watching closely part of this story. Back in the summer of 2025, following the 2024 explosion, the Yellowstone Volcano Observatory installed a brand new permanent monitoring station right there in Biscuit Basin, specifically so they'd have better instrumentation in place if that area ever acted up again. This June's explosion occurred roughly 100 meters, a little over 300 feet, from that station. Scientists with the observatory have been very direct about what that means. No hydrothermal explosion in Yellowstone's history has ever occurred this close to a dedicated monitoring station before, which means if there were any seismic or acoustic precursors in the minutes, hours, or days leading up to that explosion, there's a very good chance the instruments actually captured them. That is an extraordinary opportunity for the scientists studying these hazards, because right now, one of the biggest open questions in Yellowstone hydrothermal science is whether these explosions give any advance warning at all, or whether they simply happen without notice. Researchers are now spending weeks combing through that dataset, and this event may end up being the clearest window scientists have ever had into what a hydrothermal explosion looks like in the instrument record before it actually happens. When the geology team got out to the site and mapped what had changed, they found a fissure about 18.5 meters long, just over 60 feet, running north-northwest, filled with near-boiling water, and up to 5 feet wide in places. Multiple new vents had opened up, grouped into northern, middle, and southern clusters, and in the days following the initial explosion, between June 14th and 16th, an entirely new pool formed at the site as ground around the vents continued to collapse and settle. By the time scientists got a good look, only the northernmost vent, the one farthest from Black Diamond Pool itself, was still actively discharging water into the river. So this wasn't a single clean explosion and done. It was an evolving hydrothermal feature that kept changing over the following week. And that evolution itself is valuable scientific data about how these systems behave once they're triggered. Now, here's why I keep separating this out from anything to do with Yellowstone's supervolcano risk, because I think it's the single most important context for this whole story. As of the most recent monthly update from the Yellowstone Volcano Observatory, the caldera remains at a normal alert level, with the aviation color code sitting at green, which is the lowest, calmest designation on the entire scale. Earthquake activity through the month of June was entirely at background levels, 118 located earthquakes total, which sounds like a lot until you understand that's completely typical for Yellowstone, and the largest of them was only a magnitude 2.4, which most people wouldn't even feel standing right on top of it. On the deformation side, meaning whether the ground itself is rising or sinking, which is one of the clearest indicators scientists watch for actual magma movement, the data shows no significant uplift or subsidence of the caldera or the North Caldera Rim going back to January of this year. There was a period of uplift on the North Rim that started back in the summer of 2025, but that uplift ceased by mid-January, and the ground there has essentially sat still since then. None of that describes a system showing signs of an impending eruption. It describes a system doing exactly what Yellowstone does every single day of every single year, venting heat, shifting slightly, producing small earthquakes, and occasionally producing a small hydrothermal explosion, which is a completely different animal from a magmatic one. I also want to touch on something else that came out recently because it's a genuinely new piece of science. Even if it's not the kind of dramatic warning sign the algorithm loves, researchers looking into what actually powers Yellowstone's magma system published new findings suggesting the long-held picture might not be entirely accurate. For decades, the standard explanation has been that Yellowstone sits above a deep mantle plume, essentially a narrow column of superheated rock rising all the way from near Earth's core, like a blowtorch aimed at the crust from underneath. This newer research proposes something different, a broader phenomenon. Researchers are calling a mantle wind, where hot rock is pushed sideways beneath the region rather than rising straight up from the deep interior, generating magma at a shallower depth than the classic plume model would suggest. This matters because understanding exactly how a system like Yellowstone is fed helps scientists build better models of how it might behave in the future, how long unrest might build before anything significant happens, and how the magma reservoir itself evolves over time. It's not a warning sign in the sense of something changed and scientists are worried. It's a warning sign in the sense of we're learning the fundamental mechanics of this system better than we ever have, which is exactly the kind of foundational science that eventually makes forecasting more accurate down the road. Let's zoom out for a second, because I think it's worth reminding y'all just how enormous the scale of worst case actually is here. If only so we can properly appreciate how far current conditions are from it. Yellowstone has experienced 2 super eruptions over the past 2.1 million years, events so large they qualify for the absolute top of the volcanic explosivity scale, each one releasing well over 250 cubic miles of material, enough debris to bury an entire state several feet deep. The most recent of those, 640,000 years ago, is the event that formed the caldera we recognize today, a depression roughly 30 by 45 miles across. But the last actual volcanic activity of any kind at Yellowstone, not a super eruption, just a lava flow, happened around 70,000 years ago, and scientists are clear that the overwhelmingly most likely scenario for any future activity is a small, localized lava flow within the existing caldera, similar to the more than 80 lava flows that have occurred since that last super eruption, not a repeat of the caldera forming event. The annual probability of a super eruption specifically is estimated at somewhere around 1 in 730,000, genuinely one of the rarest categories of natural disaster on the planet. And here's the part that I think should actually be reassuring rather than unsettling. Scientists have been very clear that if Yellowstone ever were building towards something significant, they would not be caught off guard by it. Precursors to major volcanic eruptions, intense earthquake swarms far exceeding background levels and rapid, sustained ground deformation typically show up days to weeks before an eruption for smaller systems. And for a system as large as Yellowstone, researchers expect that lead time would stretch to weeks, possibly months. The monitoring network in place right now includes continuous seismometers, GPS stations, tracking ground movement in real time, thermal sensors, gas monitoring, and satellite radar interferometry, all feeding data to the observatory around the clock. That's exactly the kind of network that just recorded, in extraordinary detail, a small hydrothermal explosion happening basically right on top of one of its own stations. If a genuine build-up toward a larger event were underway, that same network is built to catch it, and multiple independent lines of evidence, seismic, deformation, and thermal, would all need to show anomalies together, not just one isolated blip. So where does that leave us? Here's my honest read on this story, y'all. The Biscuit Basin explosion is a legitimately exciting scientific event. Not because it signals anything ominous for the supervolcano, but because it may be the best recorded hydrothermal explosion in Yellowstone's history, sitting almost directly on top of a monitoring station installed for exactly this purpose. Scientists are going to spend the coming weeks and months combing through that data looking for precursory signals, and what they learn could genuinely improve how these hazards are understood and potentially even forecast in places where visitors walk right past these features every single day. That's the new warning sign scientists are watching closely. Not a sign that Yellowstone's volcano is stirring, but a rare, close-up data set on the much more common and much more immediate hazard that actually affects visitors to the park. Hydrothermal explosions in areas like Biscuit Basin, Norris Geyser Basin, and other thermal areas people walk through on boardwalks every day. If you're planning a trip to Yellowstone, that's honestly the more practical takeaway here. Stay on marked trails and boardwalks in thermal areas. Keep an eye on posted closures, and understand that ground that looks solid around a hot spring or geyser basin isn't always as stable as it appears. That's the real, immediate hazard these areas present, and it's one park rangers and geologists take seriously every single season, independent of anything happening with the deeper volcanic system. I'll keep bringing y'all updates as the Yellowstone Volcano Observatory releases new findings from this event, because I do think there's a real chance we learn something genuinely useful about hydrothermal hazard forecasting out of this one. Subscribe to the channel, share this with anybody who's got a Yellowstone trip planned or who's just curious about what's actually going on under that park. And I'll see y'all in the next one. Stay curious, stay safe out there, and I love y'all.